Hello, my name is Dion Hodgetts. I currently teach in Education Queensland Independent Public School on the north side of Brisbane. I'm a learning co-teacher and a Year 5 classroom teacher. I am part of the Peninsula Cluster for Digital Technologies. I also facilitate and co-run the School Lunchtime Code Club. This is my reflection for EUN632, Digital Fluencies for STEM, Task 2. This STEM activity is based on the Digital Technologies curriculum and was implemented during a lunchtime code club lesson for years 3 to 6. Students worked in groups where they collaboratively used visual coding on iPads to program a sphero ball to move with the coloured light turned on, recording the trail or lighting painting photographically. The content descriptions for digital technologies stipulates what teachers are to teach within the classroom. These content descriptors include knowledge, skills, and understanding for each learning area. I've chosen these content descriptions as seen below to direct the teaching of this task and provide a guide to support students' learning needs and interests. In groups, challenges were developed that presented opportunities for students to create code for the creation of specific shapes for their light painting. Using a leveled approach to support students of varied abilities, squares, triangles, and spiral tracks for the sphero balls to draw emerged. From this starting point, all students were able to dig deeper into some of the following concepts: the properties and behaviour of light, photographic processes, angles, distance, shape and size, the elements of art and design, particularly colour, shape, line and composition. In teams, students came up with solutions using algorithms to work collaboratively. This skill is about learning the language of our 21st century digital natives. The STEM activity was extremely engaging for students, but it required and reinforced several digital fluencies. Students' attitude and confidence played a major role in how students attempted the activity and their willingness to work collaboratively within their group. This collaboration built student fluency through communication, innovation, and curiosity. Students had an understanding of visual coding through code clubs, so their digital confidence was already implanted. Students used problem-solving skills of computational thinking to resolve complications which are vital to digital fluency. Using a touchscreen and an iPad is a skill students need. Students need to know how to click and drag and navigate. This helps students steer the Sphero EDU program with precision. Photographic skills were important when it came to students photographing their light code and also being able to use video to capture the Sphero implementing their ideas. Lastly, the need to develop grit and perseverance in facing challenges was vital to the accomplishment of accurately finishing the task.
2, 1,
One of the great things about this kind of task is hearing the students' conversations as their group engage with the knowledge of visual programming, experimental ways of working, and their digital fluency abilities. In addition, it is extremely engaging in estimating and making predictions, jumping between the sphero ball and photographic equipment. Hypotheses developed and tested with many decisions emerging through trial and error. Problems are solved on the spot and success develops through an iterative process and effective collaboration. Best of all, the fails happen over and over again, leading to students' independence, creative and critical thinking, and some really fulfilling moments when the desired outcome was achieved. No temporal constraints were detected within this task, although some spatial constraints were seen within implementing it. It embodies many of the inquiry-based learning model processes by engaging students to learn by investigating scenarios and problems and through social experiences. Activity theory exists within this task in the relationship between subject, the human doer, and object, the thing being done, to form the core activity. This theory can be seen clearer in the next slide. The elements of this model, subject, object, tools and signs, rules, division of labour, and community, emphasises the distinction between the object or motive of an activity and its outcomes. The object of an activity encompasses the activity's focus and the purpose, while the subject, a person or group engaged in the activity, incorporates the subject's various motives. This task looked at the subject, tools and signs as an identified challenge due to teacher knowledge, resources available, facility adequacy, visual strategies, and Wi-Fi issues. It also identified that subjects to rules was a challenge because of student collaboration, actively participating, and respecting each other and equipment. Students developed the necessary skills for controlling their sphero balls by creating their own code. Using an inquiry model and leveled approach, students created programs that would see the sphero drive through paths, creating zigzag shapes, etc. Simple squares, triangles, and more complex ideas such as spirals and the NVSS logo were produced in code, with students also thinking about creating changes in Sphero's glowing colour. The codes were then tested and shared amongst the group in preparation for the next exciting phase, light painting. Students worked in groups with one iPad operator controlling the Sphero movement and the others operating the camera to capture images and timing. Communication was key, as the camera and Sphero need to be coordinated. To create the kind of student-created images, you need to have a dim room and a steady support for the iPad or iPhone camera. In our session next time, we should use tripods to shoot from elevated position, which would allow us to capture the floor with a clean and consistent background, along with stability of the camera, as is important as the long exposure creates blur with any movement. The Sphero activity provides students with multiple opportunities to critical and creative thinkers. Digital technologies are part of the Australian curriculum, general capabilities, and a crucial 21st century skill that is spread throughout this activity. It provides an authentic framework which engages students in inquiry learning. The ideas presented here are so flexible they could be applied to exciting learning opportunities in science, math, technology, etc. Considered lesson design is key in the direction of the activity. See below table for learning areas that could be implemented into this task. There are many opportunities for light painting and image construction. Students can combine their works, add filters and effects to extend on their starting points. Also, the use of slow shutter app to draw and paint with any handheld light source. Lastly, STEM offers an engaging hands-on learning to inspire students to be inventors, thinkers and innovators. Building a solid STEM foundation through a well-rounded curriculum allows students to develop their critical, creative and collaborative skills. Today's students are tomorrow's leaders. Thank you.